Okay, I'm gonna take a few examples of the chain rule, right? And this rule, just to remind you, it is used for composite functions. Okay, so if we have a function of a function, let's say f of x equals sine of x squared plus e to the x plus 1. Okay, then what we basically doing here is that we have a function and we have another function. Now this function is composed of another function, so it is a composite function, and this is y, and we have to find dy over dx. Okay, so when you talk about the chain rule, what you do is we can just put this whole thing equal to, let's say, phi. Okay, then the function would be sine of phi, right? Now phi is another function of x, so phi is a dependent variable and it depends on x. If we differentiate both sides here, we have dy over dx. Okay, we're differentiating with respect to x, equals to cos phi, and since phi is a function of x, you have to differentiate phi with respect to x. So what I'm basically doing here is that I'm rewriting dy over dx as simply dy over d phi times d phi over dx. Okay, you can see here that cos phi is simply dy over d phi. Okay, if you differentiate y with respect to phi, what do you get? You get cos phi, right? So cos phi d phi over dx. And now I can just put in the value of phi from the given question. I've substituted x squared plus e to the x plus 1 to be phi, so I just put the value back and I get dy by dx equals to cos of this whole thing here, which is x squared plus e to the x plus 1, and d phi by dx is simply the derivative of phi with respect to x, which is 2x plus e to the x. Okay, so the whole thing comes out to be this, and this is your answer. Okay, so using the chain rule here, okay, it goes like a chain, and you always start from the outermost function and you move on to the innermost function. You'll notice that in the upcoming examples. Okay.